Hello and welcome to DNA Today. I'm your host, Kira Deneen, and I'm talking about what's happening in the genetic world. The show is packed with news stories, lessons, all to keep you updated and educated on the ever-changing world of genetics because it moves so fast, it's hard to keep up with even on a weekly basis. You can tune in every Monday at 11:30 a.m. to hear me live on whus.org or on the radio 91.7 FM. Today I'm talking about the 100,000 Genomes Project. So what is the 100,000 Genome Project? You may have heard of it. Genomic England is a company owned by the Department of Health and was set up to deliver the 100,000 Genomes Project. And this flagship project will sequence 100,000 whole genomes from the NHS patients by 2017. So by the time I graduate here at UConn, that's how many whole genomes will be sequenced. At least that's the aim. So what are the four main aims that Genomics England has? So the first one is to bring benefit to patients. Obviously, that's going to be the main reason they're doing all of this. The second is to create an ethical and transparent program based on consent. So they're really focused on having informed consent and having the patients understand how the data is being used, how it's going to be taken from them, and a lot on that concept of informed consent, which is something that I think I'm going to talk a lot about coming episodes about informed consent. I'm learning a lot about this in one of my genetics classes and just how important it really is. So I'm definitely going to be sharing a lot about that and a lot in history of times that informed consent has not been a primary concern. And this has really changed in the field of science where we are now focused on informed consent, whereas in the past we haven't been. First name comes to mind is Henrietta Lack. She did not have informed consent when cells of hers and tissues were taken from her to use for research and eventually used for so much. So definitely going to get into that on a different episode. But informed consent is so important. Another aim of Genomics England for this project is to enable new scientific discovery and medical insights. And the last one is to kickstart the development of a UK genomics industry. And something worth mentioning is that this isn't happening in the US, but I'm talking about it because it's a huge deal. And because of media and everything, we are able to really be giving information to each other with genomic information, so much information that we're able to share information very easily, especially with databases, uploading all of this. So this is happening in the UK, and Genomics England kind of gives the name away there. So the project is focusing on patients with rare diseases and their families, as well as patients with common cancers. So they're really focusing on rare diseases and common cancers. The project involves collecting and decoding 100,000 genomes, and this complete set of people's genes and all the DNA in between genes. So we're really looking at all of the DNA that someone has, not just the coding part that makes proteins, but also the non-coding part that has been considered junk DNA in the past, but we're realizing how important it is now and discovering more of that and really exploring that. So this will enable scientists and doctors to understand more about specific conditions. And I talked about the Rare Disease Day that I attended last month, so I thought this was very fitting to talk about this project that's happening and so much in the news just the past couple weeks for them and all of these updates of what they're doing. It's no longer something that they are going to do. It is something they are doing. So very timely news. And just talking about rare diseases before, I'm definitely going to be focusing on rare diseases more in this show because I think that we need to shed a lot of light on that. And, I'd like to provide more insight on rare diseases, especially in the U.S., but obviously globally as well, on this show, and hopefully get some people on here to talk about their rare diseases and, how they're fighting them and how, possibly they're fighting legislation to change things. So Secretary of State for Health, Jeremy Hunt, announced the project back in 2013 in July. So he's kind of heading this project, and he announced it publicly to everyone. So I want to read a quote that he shared about this project. Quote, "The NHS has a long track record as a leader in medical science advances, and it must continue to push the boundaries by unlocking the power of DNA data. The UK will become the first ever country to introduce this technology in its mainstream health system, leading the global race for better tests, better drugs, and above all, better, more personalized care to save lives. Genomic England will provide the investment and leadership needed to dramatically increase the use of this technology and drive costs down." So this is something that I have talked a lot about on this show of personalized medicine. And this project is really going to jumpstart personalized medicine and we're going to find a we are sequencing all of these genomes, and by having a database of all these genomes, we're going to understand better genes and how they're working and how they differ between people, because if you have a huge base to work with of so many different genomes, you can see differences between them. We have the Human Genome Project was huge, and we now have a draft of the human genome, the entire human genome. So now that technology is better and we are able to do this with less costs and less time, that this will be able to really, this project is taking off, and the base of this project was the Human Genome Project, which I've talked about in the past, and it's that really, if it wasn't for the Human Genome Project, we wouldn't be able to be where we are today. One of the concerns of Genomics England in this project is the security of patient information, but they claim to store the data following NHS rules to protect the information. So who exactly will have access to this data? Because if you are part of this study and you're giving, your DNA to them to look at, you may be a little bit concerned of who's going to be looking at this. Could it possibly be employers, my future employers, that they may not want to hire me if they see that I potentially may have this terminal disease, that I'll die very young or something of the sort? So the answer that Genomics England provides is that NHS clinicians will have access to data on participants in their care. They will already have most of this information, but the genomic data and results of analysis may lead to a new diagnosis or different course of treatment. So because of this information, they may be able to better serve the patients. So the patients, it's very, very beneficial for them to join this program and have their genome sequenced, because there are already, that I'll get to in a little bit, success stories of, wow, we've been able to identify something and now you're getting treated for, or now we know what to look for in your family. So there's a lot of benefits to doing this. Researchers will also be allowed to access to de-identified subsets of the data for approved research purposes within a secure monitored data environment, and both academic and industrial researchers will be allowed to do this. It's going to be available. And it's important that Genomics England allows users from industries to access the data, because if new diagnostic tests and treatments are coming from this project, they need to be developed, as they always have been, by the private sector and not within the government or NHS. So it's really important to have that kind of dialectic going on of putting information out there and having it available for multiple types of people, and talking about private sectors and government. So we're not just looking at one or the other. It's kind of a fluid passing of information. Now, the NHS clinicians will have access to data on patients in their care free of charge. Academic researchers participating in the Genomics England Clinician Interpretation Partnership will also have access to de-identified data free of charge, subject to their research subject being approved. Users from industries will need to make contributions towards the cost of the project, which will fund, for example, the storage of the data, because there is so much data that obviously there's going to need to be money to back up the storage of it. And Genomics England has not yet finalized these charges, so they're figuring it out, and they're currently working on the best model for the future, because this project really is just starting out. So it's very exciting to learn what they're doing now, so you can kind of follow along. So how are these patients going to stay anonymous? They are actually taking their DNA and analyzing it, which kind of has their fingerprints all over it. So the data made available to researchers will have direct identifiers removed. Researchers should not be able to work out who this data is about, or even who is participating in the project, simply by looking at the information in the system. So there's going to be a separation of the information. However, any non-trivial piece of health data, even a de-identified report of an appointment booking, could be re-identified by someone who has already had enough information about the individual in question. So this is why Genomics England insists all access to its data takes place within their secure monitored environment, because we are looking for the patient's safety, we are looking for informed consent, and making sure that the patient is obviously top priority, and we are not messing around with that at all. Now, the company is chaired by Sir John Chisholm, who is the former chair of Medical Research Council, and Sir John shared a great quote that I want to share. He said, quote, "This project represents a great opportunity to translate our world-class genomic science into world leadership in genomic medicine. Genomics England will create a data set of anonymized whole genome sequences matched with clinical data at a scale unique in the world. Participating patients will have the opportunity to benefit from clinician insights derived from the sequencing of their genome, while at the same time contributing to knowledge which will be valuable to the whole patient community. It is from that knowledge that world-leading therapeutic products and processes will become available to all patients. So basically what he's saying here is that the patients joining this have awesome benefits available to them because they have access to these doctors that can, and other professionals that can look at their data, their DNA data, and be able to possibly figure out new treatments for them that have not previously been available to them. They also may be able to develop more treatments and maybe even more cures to be able to help them through this project. So this project seems very dynamic in that it's not like they're collecting all the data, then analyzing it, then helping people. From my understanding, it seems like they are taking the data and helping people kind of on a one-on-one basis, especially at the beginning of this. And I've mentioned before that at least 80% of rare diseases have an identified genetic component, with 50% of new cases of rare diseases being identified in children. So it's because of these numbers that the 100,000 Genomes Project is vital to finding new ways to diagnose, treat, and cure rare diseases, because they are taking individual genomes, analyzing them, and giving them treatment. So being able to work one-on-one and have that personalized medicine is really key in this. But on the grander scale, they can take this information and apply it to larger groups of people. So it's really the best of both worlds here, that we're looking at treating the patient that they're taking the data from, but also being able to apply it to maybe the rare disease they have in that community. I've talked about how much it would have cost before to do certain things, such as sequencing the whole human genome. And this is dramatically reduced, and it will become more affordable and more routine as the price continues to fall. But let's compare. So in the past, like say 13 years ago, it took 2 billion pounds, and now it only takes 2 days. In order for the whole genome to be sequenced, it would take 13 years to do and cost 2 billion pounds. But now it only takes 2 days and 1,000 pounds. So just in a little over a decade, we're going from 2 billion pounds to 1,000 pounds, which is a dramatic change. And previously, we've also only looked at 5% of our genes, as they were thought to be the only relevant genes, only working genes to look at. We thought, well, the other ones aren't producing proteins, or they're not as active, so we're not really going to look at those. We're only going to look at 5%. Now, we look at all the genes, and we're also looking at that non-coding part. So we're realizing how important it is, and how important it is, we're not sure why it's super important, but we know it's important. So things have changed in the last decade, going from 2 billion pounds to 1,000 pounds, and in so much less of the time. 13 years it used to take, and now it takes 2 days. So that's why this project is able to do, to continue and persist, because it takes so much less time. And around 15,000 patients with rare disease will take part in this study, and around 25,000 cancer patients. So again, they're focusing on rare diseases and also cancer patients. Those are their two main focuses. Chief Medical Officer Professor Sally Davies shared, quote, "By putting firm foundations in place through Genomics England, this technology will let us make groundbreaking discoveries about how diseases work, who could be susceptible to them, how we can treat them, and what treatments might work. Earlier diagnosis will help us to reduce uncertainty and stress from patients and families involved." So again, patients really have a lot to gain through this. So there's been 2 news stories surrounding the 100,000 Genomes Project, and the last one of them was March 11th, and this was a great news story that talked about the first patients that were diagnosed through the 100,000 Genomes Project. So I mentioned him before. The Health Secretary, Jeremy Hunt, met these patients, and they were diagnosed with rare diseases through the 100,000 Genomes Project. And due to these diagnoses, these patients will now receive effective personalized treatment. Personalized. I really want to stress that word. So they're not only are they going to receive this personalized treatment, they're also going to help prevent future generations who share their DNA from suffering a life of uncertainty about similar symptoms, that they'll know, well, this rare disease runs in our family. You may have it. That's probably what you're experiencing. Now, this pilot kind of sub-project, I guess, of the of Genomics England project was completed with help from Newcastle University and hospitals. So let's take a look at the patients who were diagnosed from this pilot portion of the 100,000 Genomes Project now. So Leslie Headley, 57, has had a long life history of high blood pressure causing his kidney failure, and his first kidney transplant failed, and he has received a second transplant. Now, his father and uncle died of the same condition, and his daughter, Terry Parker, 34, has early signs of kidney damage. So she's kind of expecting that she's going to have the same thing as her father, and her father, same thing as his uncle and his father. So it really is running in the family here, so we can kind of see it's a genetic thing. Now, there was a concern that his daughter that Terry's daughter could also be affected. So, what did this whole genome sequencing reveal about the Headley's condition? So it's revealing that the kidney failure has caused by a particular gene variant. Now, the family's being tested for this genetic variant, and their blood pressure can be regulated by drugs on the market because they were able to identify it as a genetic variant, what genetic variant it was, and now they can test the family. So just in this one thing, just in this one little one patient and their family, they were able to discover so much about it. And Leslie shared why he wanted to take part in this project as a patient, and he said, quote, "I was keen to take part in the project as I felt it was important to try and figure out as much as possible about my condition for my daughter and my granddaughter. Now that my daughter Terry has been given a diagnosis, it means her condition can be monitored every year to see if there are changes. Research has come a long way, and it's important that we do our bit to help as much as we can." So, he's really looking at giving back to the community that he has been able to have a diagnosis and treatment as well as his family. So he's looking to give back. His daughter, Terry, also commented, quote, "The 100,000 Genomes Project is hugely important in gaining as much insight into rare diseases as possible. I wanted to be a part of the project for the benefit of my daughter, Katie, and it was such a relief when we found out that she did not have the same rare kidney disease as myself and other family members. I'm glad I've been a part of the scheme and that I was given the opportunity to contribute, as it is a step forward towards finding out more about rare diseases and developing personalized treatment." Now, the second family to have benefited from the pilot part of this project are brothers William and Alan Carpenter, aged 79 and 69, and they've suffered from muscle loss and weakness. So through the project, they've been diagnosed with inherited nerve damage known as peripheral neuropathy. Now, what is groundbreaking about their condition, it is the first time this particular genetic mutation has been identified. So already in this project, we've identified a brand new genetic mutation. And it's possible that William and Alan will be joining a treatment trial for possible success to prevent their family members from getting this disease and just discovering more about this disease. Now, Professor Patrick Chinnery, who is the director of Institute of Genetic Medicine at the Newcastle University, shared his insight on the pilot portion of this project, saying, quote, "Patients of Newcastle Hospital are the first to receive diagnosis through whole genome sequencing by Genomics England, leading to changes in the treatment of NHS can offer their families. Knowing the genetic cause will allow the NHS to give best treatment possible to these families." And Genomics England Chief Scientist Professor Mark Caulfield said, quote, "The 100,000 Genomes Project are delighted to be returning our first diagnosis to families with rare diseases from our whole genome sequencing. More will follow over the coming months." So we're really looking at this project really getting started and already seeing success and already having success stories. So it's very exciting to hear this. And so after this pilot portion of the 100,000 Genomes Project, St. Mary's Hospital became the first NHS Genomic Medicine Center to recruit patients to the 100,000 Genomes Project. And March 19th, Michelle Holding, age 32, was recruited to the main phase of the project. And Michelle shared with the Manchester Evening News, saying, quote, "This sort of research is going to allow future generations to be diagnosed quicker, to be treated better and more efficiently, and that has to be a good thing. It's amazing to think that by doing this, I could be helping future generations of people." Professor Bill Newman, who is a professor of translational genomic medicine at the Manchester Center for Genomic Medicine at the University of Manchester, an honorary consultant at Central Manchester University Hospital's NHS Foundation Trust. He shared that it was a pleasure to meet the family today in our Manchester clinic, who became the first participants in this major study. We discussed with them how we hope to find out the reasons why so many young women in their family have developed breast cancer. We have confidence that this new type of genetic sequencing test will find answers to make real difference for other members of their family and future generations. So St. Mary's Hospital is one of 11 of the NHS Genomic Medicine Centers across the country that will lead to the discovery of the 100,000 Genomes Project. And this project really is just phenomenal that we are able to look at sequencing this many genomes, 100,000 by 2017. So we're looking at, in the course of 2 years, we're able to to sequence all of these genomes and pull information from it and really create this database of so many genomes, because we really don't have that right now. We have the Human Genome Project got us our first draft, but now we're able to really focus on having a fluid database of information being added, and all right, we found this treatment, and making a note in that, with that genome that, okay, well, this person has this rare disease and we were able to treat it with this, so that if someone else comes in with a similar rare disease or even the same rare disease, then they can say, well, this worked for this patient. Your genomes, say you have the same genetic variant. Wow, you have the same genetic variant. Why don't we try this treatment because it worked for someone just like you? And that's how it's personalized. That's how we're changing things. It used to be that you would have something and they would guess at medication and throw it at you. And of course, that's still happening. However, things are changing and things are shifting to be more personalized. So we are taking medicine that, instead of this could work for you, saying, this is kind of designed for you, that it's designed for people like you, not specifically one person, but it's designed for someone that has a genetic variant like you. So it's very dynamic. Things are happening quickly. I mean, the dates I'm mentioning are just this month, March. I'm talking about March 11th, March 19th. The first patient that was diagnosed through the 100,000 Genomes Project was March 11th. And the first one that was recruited was 100,000, or that was March 19th. So this really is happening very fast, and it's very exciting to see. So you can find out more about the 100,000 Genomes Project through their website at genomicsengland.co.uk, and you can follow on Twitter at Genomics England. I definitely see them tweet quite often, so you can be sure to check them out there. And if you're on Twitter, you can follow my show at DNA Podcast, or my personal Twitter handle at KIRADINEEN, Kira Dineen. Check out the website, dnapodcast.com. There's all kinds of good stuff on there. And if you want to request more stuff, you can email in at info@dnapodcast.com. If you know someone that has a rare disease that you think would be a good fit for the show, to interview them, I'd love to hear that. Or if you have anything to do in the field of genetics, or you want me to learn about something and share it on air, info@dnapodcast.com. Thanks for listening, and join me next week again, Monday at 11:30, to learn and discover new advances in the world of genetics.